Yeah, so they're giving us this great big polynomial. This is a 6-degree polynomial. And it has 3 as a 0, a multiplicity of 2, and 2 as a single 0, -1 as a single 0. It says find all other zeros of f. Well, first off, how many total zeros are there? There are 6 zeros. And so we have, well, I sure did not give you guys enough room on this. We have, I guess I did. We have, how many will we give? We're given 3, right?
3 or 4.
We have 3 by multiple, so 3 and 3. We have 2, and we have -1. We're given 4 of the 6. What can I do with that to reduce this down to a smaller polynomial? Synthetic division. In fact, I'm going to use another sheet of paper because I should have given you guys a lot more room on this. But I'm going to take and divide this polynomial down by each of these. Each time I divide it, it becomes a smaller polynomial. If I can get it down to a quadratic, then I can use the quadratic formula to solve. So that's really kind of the goal always of doing these. So synthetic division. Alright, so I start with my coefficients. 1, -5, 3.
Why do you have 2 3s?
Yeah, because the 3 has a multiplicity of 2. So, and and that's critical. If you didn't catch that, then that would make this almost an impossible question to do. So I had to give you really 4 of those 6 to get this to work down. 1, 40, -24, and -72. And it doesn't matter what you start with, you're just going to start dividing by each one of these. And so the 1 comes down, multiply, that's -6, 3, -9, -8, 24, 16, 48. 3 times 24, hopefully it's 72, isn't it?
Yep.
Right, and I know I need to get zeros out there. If I don't, there's a mistake someplace. Now remember, I divide by the next 0. I divide my quotient by that. I don't start over again, so I'm going to divide by 3 again. I think that'll work fine. Put my 3 up front. I just like to just continue on. Yeah, there's not enough room. I apologize for that, on what I was thinking. 1 comes down, 3 to 0, -24, which would be -8, and that works again. Also nice about this, you're not dividing by imaginary numbers. When doing the assignment, you probably were frustrated by that, no doubt. And then I'm going to divide again, right? Divide by 2. No, I'm not. If you want to get some yellow paper, you come get some yellow paper from me. What? So 1 comes down, multiply. That would be 6, 12, 4, and 8. That's good. And finally, we divide by -1.
So if there's a multiplicity, that's when it touches it and it doesn't go through it.
Mm-hmm. Okay, so we have to find the last 2 zeros. Now I've got it down to a quadratic. Right? My final quotient here is x squared plus 2x plus 4. So, what are my options on solving that? I either can factor it or quadratic formula, but factors of 4 that add up to be 2, I don't think exist, right? So,
Unless you like got really tricky with it.
so let's use a quadratic formula on that.
Like 1 through 4.
Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so we have 4 minus 16. Is that possible?
That's a negative.
Negative 12. So how should we rewrite the square root of negative 12?
Negative 2 plus or minus 2i root 3.
So it's 12 is 4 times 3. So yeah, so 2i root 3 over 2. Oh, we can divide both those by 2, can't we?
Yeah.
So how about negative 1 plus or minus I root 3 or root 3i, either way. And after all that, the question asked me to find the other zeros. There are the other 2. And you're welcome to write it like that, or you can write it as 2 separate ones, negative 1 plus I root 3 or negative 1 minus I root 3.
Can you just give us like 5 pieces of extra paper on the test?
I'll give you some extra paper. I'll do my best to leave more room, because it helps me in the grading as well, and I have enough room there. But yes, I should have done that. So I'm going to go back and write those in then. So we had the negative 1 plus I root 3, or root 3i, doesn't matter how you want to write that. I'll take that either way. And negative 1 minus I root 3. Alright, now look at this one. It wants us actually to sketch out this graph using these zeros and end behavior. Now a couple things, remember. Do the imaginary zeros show up? Not at all, right? They're imaginary. The graph itself is only real numbers, so they do not show up. So we have zeros then at negative 1, at 2, and at 3.
And it only touches at 3. Right?
Yeah, so my end behavior, right, since it's an
Both goes up.
even power and positive, both are up. So it's going to start there and end up. An odd multiplicity goes through, and even it just touches. So at negative 1, the multiplicity is, there's 1, right? One of those, so it's odd. That's an odd number. And it goes through there. And then at 2, there's only 1, 2, right? That's odd. So it goes through there. And then it has to come back down to here. But at 3, it's an even multiplicity. So I'm going to touch it and go back, and then it goes back up, and there's my graph. When I say it is sketch, remember I don't know, and I'm not going to ask you how far it goes down here. It goes down a certain amount. Here it goes up a certain amount. And I don't know that either. Remember as well that you are welcome to graph that on your calculator, check out the answer as well. So that would be fine. Okay, are we good? Okay, look at 8. So 8 is another one that's a little challenging. But you may want to recognize on 8 that it has an x to the 4th and an x squared. And in fact, that kind of gives you, that looks like almost like a quadratic, doesn't it? And so in fact, we're going to rewrite this and solve it as a quadratic. So remember kind of how we can do that. We're going to let we're going to do a substitution. We're going to let u equal x squared. So if we do that substitution, then f of x would equal Okay, so it's 4 times. So x to the 4th is like x squared squared. So that would be like u squared. Minus 21, well, x squared is u. Minus 25. Now we got, in doing that, right, now it's a quadratic, which means I can either factor it or use a quadratic formula. Does it factor? It looks like it might. Let's play with that just a little bit. If you don't see it factor so quickly, you may want to go ahead and move on. I know, though, that if I have 4 u and u, factor, this is kind of interesting because look, factors of 25 are actually 1 and 25. If I make this a minus 25 and a plus 1, I mean, does that work?
The opposite.
Oh, that'd be a plus.
No, flip the numbers. A negative 25.
Oh, yeah, this should be a negative 21 here. And this would be a plus 1 here.
Negative 25.
25 and a plus 1 there. That works? The outside would be negative, but positive 4u and negative 25. Yeah, that does work. That's nice, because now we can set each of those equal to 0. So either 4u minus 25 equals 0. So what's u equal to?
U equals 25/4.
Or u plus 1 equals 0. So u would be... Alright, now the problem is yet I can't stop there, because the question says find the zeros for this one, which is in terms of x. So now we need to solve for x. So we know then that x squared is equal to u. So that means that in the first case, x squared would be 25/4. So if I solve for x, what do I do to both sides? So I take the square root of both sides. So x is going to be plus or minus 5/2. And then I do the same thing with the other one. X squared is equal to negative 1. So, square root of both sides, what do I get? Plus or minus I. So in fact, I end up with 4 zeros. Plus or minus I and plus or minus 5/2.
What's the one on the parentheses? On the right.
This
Plus,
is u plus 1.
plus 1.
Yeah. Okay.
How do
That-
you check on 7B? What do you put in the calculator to check your work?
7b. Yeah, so I would just type in this big long polynomial.
The graphs didn't match up.
They don't match up. Let me try it. So we have x to the 6th minus 5x to the 5th plus 3x to the 4th 40x squared, 40x x squared minus 24x, oops,
Oh, never mind. Maybe match up.
minus 72. Alright, make sure I got this right. So x to the 6 minus 5, x to the 5th, 3x to the 4th. I forgot my x, that's not good. Is that okay? Looks like it.
Yeah.
It doesn't match. Mine doesn't match.
Mine did, like after I put that.
5x to the 4th, x to the 5th, 3x to the 4th, I missed an x to the third, didn't I? That's why. Yeah, you gotta be really careful on these. Maybe now. Yep, there it is. So now it comes down through -1, back up through 2, then touches here. Obviously, it goes down a long ways here, right? And we didn't, and we didn't cover that. And you may want to set your window. You know, I could go from -5 to 5. It may look a little more like mine this way. Yeah. So anyway, so I encourage you to do that on the test. Use those graphs. They're very helpful. These graphing calculators are a great tool. Check all that out. All right, Bees wants me to what? Sketch this graph. Again, sketch graph using the zeros in behavior. What zeros show up on this graph?
5 half and -5 half.
Yeah, I only have 2 zeros. The multiplicity is 1 of each. Let's go through those. 5 halves is what? 2.5. So my zeros are here and here. And what's the end behavior of this graph? So the end behavior is both up, right? So it's basically going to come down so far, then come back up like this. So not a real exciting graph. But now we can look at C. So C says, use the graph to find each inequality. Where is the function greater than 0 at? Again, make sure we can read the graph properly. F of x, right, are the y values, but you want to give the x values what happens. So where is it above 0?
Or yes. -5 halves.
Right. It's above this from this section here, right?
So
So
you're giving the x values for that?
you're answering the x. You're looking at the y to determine that. Here we're above here, right? So it means we have to give these x values and these x values where it's above. So it's going to be from, use interval notation, -infinity to
-5 halves. Something like that.
open or closed.
Close.
Closed because of this equal, right? Which says that actually that means the point on the graph is a solution. And then closed again. Then the other question is, where is it negative?
-5 halves.
Yes, negative right down here. This part's negative. That's below, so that's, the x value is right between here and here. So that's going to be from, and open or close brackets. -5 halves to 5 halves. Okay, we've got what left? 2 pages, 2.5 pages. Let's do 9 yet, and then we'll finish it tomorrow, the rest of it.
Yeah.
Oh, this would be positive, yes, thank you. Ooh, don't make that mistake. Yeah, so it's positive 5 halves. Yeah, otherwise it would have been all real numbers, which would have been bad. Yeah, thank you. On 9a, how do I list all possible rational zeros?
You do P over Q.
So the p are factors of what number? So factors of 22, which would be 1 and 2,
And
11,
11.
and then the Q factors of should be 1 and 3. I'll try not to give you one like 30 or something like 90 or one that has like unbelievable amounts. But even on this one, we got to take each of these and divide by each one, right? You can't leave your answer like this. It doesn't give my ratios. I need to list out all the P over Q possibilities. So I've got 1 over 1 and 1 over 3. 2 over 1, 2 over 3. 11 over 1, 11 over 3, 22 over 1, and 22 over 3. So it's,
You're gonna do it in that order.
yeah, the order, I'm not going about the order. I'll just check them off. There are 16 possible ones on this. Okay, then the B says to find all the rational zeros. Now you have a couple of choices on this. One option is just start checking these, right? Which is there's 16 possibilities. It could take a while. I am okay if you want to graph this out to try to eliminate those down a little bit. So my suggestion is to first graph this on your calculator, try to eliminate or try to find something that may work. Then try those. So let's see if I can enter this one incorrectly. 3x to the 4th plus 5x cubed minus 35x squared minus 55x plus 22. Ooh. Okay. So I see a number of them pop up. Do I see any on my list that I have? Looks like negative 2 would be a good choice.
4. That's a fraction. I think the other one's a fraction.
We need to. How many do we need to find for sure to get this down to a quadratic? We need to find 2. Negative 2 looks like a good choice. We got to find one more. Let's see. So maybe a third. With a third, that one like a third right here.
I would put in the third.
We can try that. So let's try a negative 2 and a third and see how close we get.
Let's try negative 2 first.
Okay, so we have 3, 5, negative 35, negative 55, and 22. So negative 2.
Negative 2.
Negative 60, wait, no, 66. That's going to be 11. So that does work. So should we try a third next? Okay, let's try a third.
It works too.
3, 1, 0, 0. And, oh, it does work. Okay, so we found 2 of them. But now we got a quadratic. So now we got to see how we can always solve a quadratic. We have 3x squared.
Would this be x minus 11 for each one?
Well, okay. So if I add the 33 right, we got 3x squared equals 33. X squared equals 11, you said? Now, why can't I stop here, though? There's a reason I can stop at this point.
There is or isn't?
There is. What's the question asked for? It doesn't say find all the zeros, it says find all rational zeros. What kind of zeros will these be?
They'll be irrational.
They'll be irrational. Yeah, they're not rational. So in fact, how many rational zeros are there? There's only 2. There's only negative 2 and a third. There's only 2 rational. These would be irrational, so we don't need to find them.
But if we found found them, would you be tempted off?
If you called them rational, yes. So by definition, I wanted rational, not irrational.